Hello, I'm Mike Maquera. For my final project, I've created a procedurally generated graphics terrain generator using Three.js. Three.js is a JavaScript abstraction of WebGL. It has a large library of functions to draw 3D objects in web browsers. The project is split into two parts. First, create a randomly generated terrain height map based on a Perlin noise algorithm, then rendering the terrain map onto a Chrome web browser using Three.js. First, our height map algorithm is based on a Perlin noise implementation in Python using Python and NumPy. Perlin noise is a texture algorithm used by graphic artists and designers to enhance the realism of computer graphics such as shadows, terrain, and lighting. For our use case, it outputs a smooth collection of different heights onto a JPEG image to be rendered onto a mesh on our web browser. Our function output creates a black and white image that can be used as a height map, and the height map function works by prompting the user to enter a desired height and width of the result image. Then an array of zeros is created based on those dimensions. Next, in this for loop here, the array of zeros is filtered with grayscale values randomly, and lastly returns an image displaying a randomly generated black and white image that we can use for our height map. The most challenging aspect of this was rendering the algorithm properly to ensure the pixels dimensions were matching correctly to either PNG or JPEG files, as Three.js cannot use bitmaps or PPM files as textures. The heart of our program lies within script.js. So at the top we have a variety of header files that we are obtaining from Three.js that allows us to create two different types of geometry meshes. We are going to create a plane and a sphere. The plane, which we are declaring here, is going to be textured with our height map and also a land map that we created in Microsoft Paint. We then load these images onto our scene, in addition with some lights. To run the program, we use the command npm run dev, and it will run the program here in our web browser of choice. We can use our mouse and we can scroll in and out, and also take a moment to look at the image itself. As you can see, there's different variations of the terrain, and with the image that we created in Paint, we have a realistic looking terrain here with land, sea, and water, as well as a sun here that it's adding a little bit of light. Lastly, I'd like to give a special thanks to Daniel Schiffman of Coding Train and Gary Simon of Creative Academy for the tutorials related to Perlin Noise and Three.js for helping develop this project. Thanks for watching.